today about those two things above. So we looked previously at drawing linear graphs. Today we're going to look at graphs that are not so linear. So we're going to start off with an x squared graph, then we're going to look at how, a nice picture there, how we can change the intercepts, how we can kind of move those graphs around a little bit, and then we're going to show finally at the end how to do a simple polynomial using a graph and showing integer solutions for that. So use a little thinner pen. First of all, we're just going to start off with the basic graph, so y equals x squared. You'll notice I've drawn a little table of values. That's the same as what we've been doing before. We're going to substitute those numbers in to find the values of x squared, plot them on the graph, and then join them together. So first one we've got here is we've got the negatives. I've just chosen those three values, -3 to 0 and then 0 to +3. I could have chosen any values I wanted, but I chose to keep it nice and simple. I chose like a progression, so I've got a bit on the negative side and a bit on the positive, and it's going to cross the y-axis. So if we start off here, obviously we can see that it says -3 squared. Just remember this means -3 squared. Okay, if you type this into the calculator, you have to put it in the brackets. If you don't, what your calculator will do is it will do 3 squared, which is 9, and it will make it negative. So don't do that. -3 times -3 is +9. Okay, so all x squareds are positive. It's impossible to get an x squared that's negative for real numbers. So x squared for 2 times 2 is 4, again positive. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So when we look at these, we can see it kind of like mirrors. You've got 9, 4, 1, 1, 4, 9. And this is kind of shown in the graph. I can plot these on the graph. I can see that -3, 3 is going to be somewhere here. -2, 4 is here. -1, 1, 0, 0, 1, 1, 2, 2, and 3, 9. Now, if we wanted to, at this stage, you can just join these together with straight lines, and you'll get the rough idea of the shape of the graph. And we can see it makes a kind of U shape. I'm going to show you how to do it as a curve in a second. We can also see that it is symmetrical. If you draw a line down the y-axis like so, you can see that it's the same either side. And that's the basic shape of a y equals x squared graph. We call this a parabola. Now, if you want to join this as a curve, which is what we're going to aim for, what I try and encourage students to do is so like I'm going to do it with my iPad here, I'm going to actually turn it round, is to turn the iPad round and draw it kind of from the wrist. Yeah, and draw it in 2 halves. So I'm going to do, oh, that should have rotated, that went badly. I'm going to draw the 0 to -9 first. So I'm going to kind of just slowly and obscurely go through and beyond, and then I'm going to turn my iPad upside down, and I'm going to do the same thing the other way round. And it looks something like this. Not perfect, I know, but okay. So it should, oh, again, I'm just going to redo that so it's a bit better. You can use a pencil. At the bottom here, it has a turning point. Okay, and that's where it stops going down, starts going up. That's what makes that kind of U shape. And that is an x squared graph. Plot the points, join them together, and make sure you've got a nice, neat turning point. We can do the same thing for when we've got other graphs. Now here we're going to try and do the same thing, but this time we're going to add x squared plus 4. You'll notice that I've got this base here. Okay, I call it the base of a table because any x squared graph is going to start off with the same 2 parts, because you're going to choose some x values and then find some x squareds. Then we know that for all of them I'm going to add 4. So obviously that means that 4 is going to be the same for all of them. It doesn't matter about the value of x. And what I'm doing here is creating for myself a kind of addition table. And I'm going to add together the x squareds and the 4s. So like here, I'm going to say, okay, what's 9 plus 4? Well, 9 plus 4 is 13. 4 plus 4 is 8. 1 plus 4 is 5. 4, 5, 8, 13. So again, we've got that kind of symmetry. What is this one at the bottom? Well, it's x squared plus 4 because I've added these two together to get this one. Now again, I can plot those points. Obviously negative 3, 13 won't fit on my graph, but negative 2, 8 will. My scale's probably not the best, but we'll talk about that more in a second. Crosses at 4, 5, and 8. And again, I can kind of join them together in a nice, neat parabola. So when we compare that to the graph we just had, which was this one here, and I'm going to plot that one in green on there for you, we can see it went through 9, 4, 1, 0, 1, 4, 9. Again, we're just kind of sketching these parabolas. We can see it's basically the same graph, but it's shifted up 4 units. So this here has shifted the graph up. It's translated by a vector of 0, 4. Because all the points are 4 higher. So the same thing is going to occur again, what we were just saying. Obviously we're minusing 5 this time, so we can probably guess what's going to happen. When we added on 4, the graph went up 4. Now we're subtracting 5. Again, you don't need to write the minus 5 out every time. It's just me showing you what's happening. See, 9 minus 5 is 4. Now we're into the negatives. But we can still see that kind of symmetry. And again, we can plot those points. Negative 3 goes to 4. Then we go down to negative 1. Then we go down to negative 4, negative 5, negative 4. And then if we did actually extend this table, we could have put in a 4. If x was 4, the value of y would be 11, but that's just off our graph, so we know we can't do that one. So again, we plot our little curve, our parabola down. Ooh. Try that one again. We can turn and go up. And again, if we were to, we can see that from the previous graph, these are above, these are all 5 below what they were. So this bit here, again, is a translation, but this time it's translating down. So it's gone down. If we were to do the same thing with 3x, what we do again is we add on to our table. So I'm going to put a 3x column in here. Now this is where we have to be careful with our positives and negatives. So we can see that if we do 3 times negative 3, we get negative 9, negative 4, negative 2, negative 6, negative 3, 0, 3, 6, and 9. So when we add those together, we get our combined value to plot. So 9 minus 9 is 0, 4 minus 6 is negative 2, negative 2, 0, and then 4, 10, 18. So when we plot these on the graph, we can see that negative 3 is 0, negative 2, negative 2, negative 2, 0. Then we've got 4, then we've got 10. So again, we've got symmetry again, but it's not quite the symmetry that we're used to seeing. And we kind of, if we were to follow the parabola, it kind of goes down, turns in the middle of those two, and then it gets to here. But the graph doesn't stop, so we have to carry the graph on. So we say, okay, well, it's going roughly like this, and we just carry it on like so. And hopefully what we can see here, if we compare it to the original y equals x squared graph, which goes something like that. We can see it's kind of shifted slightly to the left and slightly down. So when we have these ones here, the shift is slightly more complicated. But the basic shape is that U parabola. Okay, last one. Now we've got 2 parts. We've got a 5x and a 6. What I'd say if you're struggling with this is that you do the 5x and the 6. So 5x, oh, can't write today. So I just do my values, times 5, times 5, times 5, times 5, times 5. We know the 6 is unaffected by the x. but I'm going to write it in anyway. And what this allows us to do, and then draw a line under that. Oh, try again. It gives us three things to add together. So for this first one, I've just highlighted them in yellow. I can say, well, 9 minus 15 is negative 6 plus 6 is, oh, need a pen, 0. 4 minus 10 is negative 4, again 0. Negative 4, they get 2, 6. This one now is 12, 20, and 30. So I might want to maybe consider doing a few other points as well. So I might think, okay, what about if I had negative 4 and negative 5? And if I had negative 4, then I would get 16 minus 16, that's a plus, minus 16 is 0, plus 6 would be 6, and then I can see the, no it's not, so I'll do the negative 5 first. Negative 5 squared is 25, minus 5x would be, sorry, plus 5x would be minus 25, so that would give you 0, plus 6 would be 6, and this one here would be 2, so we get our values of negative 3, 0, negative 2, 0, we've got a 2, a 6, and obviously the next one will be a 12, and then it's mirrored on the other side. So negative 4, so obviously for the negative 4, if I just show you what it would have been, obviously x squared would be 16, minus 20, plus 6, so it would be 2. And again, we've still got that symmetrical shape. It's going to go down, turn here, and back up. What about if we wanted to solve x squared plus 5x plus 6 equals 0? And again, we know that when we want to solve, it's equal to 0. And we can see it's equal to 0 in two places. So x is 3 or x is 2, and they're both negative. So those are the solutions. If it asks you to show the solutions, it would be something like this. And again, if we were to do another one, x squared plus 7x plus 12, again, we could fill in the same thing. And I'm going to let you try that one. And I'll just pause for a second while you try and draw that graph. So pause the video, try the graph, see what you get. Okay, if you did this correctly, I won't give you the whole graph in case you want to try it again. You should have had two crossing points. One of them should have been here, and one of them should have been, sorry. Yeah, one of them should have been here, one of them should have been here. 3 and 4. So that's an introduction to quadratic graphs. Just remember, right back to the beginning, table of values, plot your points, nice curve, make sure you've got a turning point and a nice smooth parabola.